Hey folks, this is the second video in section 8.1, and this is going to be using some examples for the law of sines when I'm given two angles. So let's go all the way down then to example number 1. Now, what you'll notice here is I've already got a few things set up for you. The first thing that I did was I just took the things that I knew. I knew angle A and angle C, so I put those into a table, and I also knew side C. So the first thing I personally do whenever I'm solving a triangle is I set up a chart. Once I can see this chart, it will direct me as to, number one, whether or not it's even solvable. Number two, it'll tell me whether I should use the law of sines or the law of cosines. And so I know we haven't covered the law of cosines yet, but this chart really helps me to know which direction to take. So the very first thing I'm going to do, and I didn't even show my work for this because it's just simple adding and subtracting. The very first thing that I'm going to do is I'm going to find angle B. And so I'm just simply going to, in my calculator, take angle A and C and add those together, subtract from 180 to be able to find my angle B, because I know that all three angles in my triangle should add up to 180 degrees. So this is the very first thing that I'm going to do. And again, showing work isn't even really necessary here. All right, now you'll notice that I've already set up my law of sines to be able to start solving. And so take a look at what I've done here. These two on top, these are my sides. This is side A and this is side C. And then down on bottom is the sine of my two angles, the sine of my angle A and the sine of my angle C. The big thing to remember when you're using the law of sines is that you have to have two things that have the same name. So this is angle C, this is side C, they have the same name. Two things with the same name have to be known to be able to have a full fraction. You have to have only one unknown to be able to use the law of sines. So I've got one full fraction, the C fraction I know completely, and the A fraction is what I'm going to be trying to solve here. So I've already got it set up, and so what I'll do is I'll take the sine of my angle A and I'm going to multiply it on both sides to be able to isolate side A. And so this is what I'm going to type into my calculator. Make sure that you're in degree mode. This is what I'm typing into my calculator, 25.3 times the sine of 28.8 divided by the sine of 102.6. I throw that into my calculator, and I'm going to get this 12.4891 number. Now, when I put this over in my chart, I'm going to have 12.5 because remember that with the significant figures, I forgot it there for a second. Significant figures, since everything else is using the tenths place, we will answer in the tenths place. The nice thing about my lab is that when you are working in the courseware, they always tell you how to round. So just simply follow the instructions about rounding. All right, so this has given me then my side A. Now I'm ready to find side B. Now, I can use the A fraction and the B fraction, but that's a little risky because what if you mess up on finding side A, then you're automatically going to mess up on finding side B. So I try as much as is possible, I try to use things that were given to me, things that I did not find. So I'm going to use the B fraction and the C fraction to be able to find side B. I've already got the C fraction written down right here, so I'm just going to write out to the side my B fraction. This then is the proportion that I'm paying attention to for finding side B. So once again, I'm going to multiply on both sides by this guy. And so what I'll type into my calculator is this. And then my calculator will spit out at me 19.4461. And so I can, again, rounding to the nearest tenth because that's what the rest of the equation did for, or the rest of the information did for me. So side B, 19.4. And one thing before I leave this example, I always look at my answers to be sure that they make sense. Let me show you what I mean. Remember the concept in math that in a triangle, the small side should always be opposite the small angle. The medium should always be opposite the medium. The large should always be opposite the large. So when I'm looking at this, here's my small side. It is opposite my small angle. My medium side is opposite my medium angle. My large side is opposite my large angle. This should always, always, always be the case when I finish with a question. It doesn't mean that you're right automatically, but at least it makes sense. Let me tell you, if your triangle does not make sense, I promise you it's wrong. So it's one thing that is a good idea to check. Okay, so let's go ahead. I'm going to jump to example 2, and then I'm going to come back to this particular example. So let's jump down to example number 2, a story problem here. It says an engineer wishes to measure the distance across a river. See the figure. He determines that angle C is this guy, so I already have my chart started and I already have this written down. He also sees that angle A is 28.8 degrees, and he knows that side B is 75.6 feet. So I already have my chart set up, and he wants to know the distance of A, which is the distance from angle B to angle C. Now, the first thing, when I look at this chart, I cannot use the law of sines because I don't have two things with the same name that I know. However, angle B is super easy to find if we use adding and subtracting. So let's just go ahead and take our angles A and C, subtract those from 180, and I'll find that my angle B is 34 degrees. So now I know all of fraction B. If I know fraction B, I can use fraction B and fraction A to be able to find out what A is. So let's go ahead and set up our law of sines. Again, this is my fraction B, this is my fraction A. We'll go ahead then and multiply on both sides by that sine of 28.8. And throw that into our calculator so that side A is 65.1306. Using my significant figures, I'll go ahead and round to the nearest tenth, which is going to be 65.1 feet. I was not asked for side C, so I don't need to do anything else to that. There is a reflection question that follows up with this, and so I'd like to take a look at it really quickly. It says, suppose that in example 2, same picture with different numbers, we're told what angle A is, what side A and side B are. So this is a whole different situation. Notice that this is going to be a side-side angle, whereas this one up here was an angle side angle. So when I look at this side-side angle, we haven't learned how to solve side-side angles yet. And so it asks me, can the law of sines be used? Well, the short answer is yes, it can. However, we need to realize that because this is the ambiguous triangle, there might be 0 solutions, 1 solution, or 2 solutions. There might be 0 triangles, 1 triangle, or 2 different triangles that might exist. And so I would need to use the concepts of the ambiguous triangle to know whether or not to solve this particular triangle and how to solve it. All right, let's go back to the example I skipped. This example is from section 5.4. It's example 8, all the way back in chapter 5. I did move some questions like this from chapter 5 into your chapter 8 study plan. And it may also show up on your chapter 8 quizzes. So you need to understand this is something that you may run across in your study plan, in your quizzes, as well as on your test. The reason that I did this is in chapter 5, the knowledge that you know in chapter 5 makes solving this question much more difficult. The easier way to solve this question is using the law of sines. You just didn't know the law of sines back then. And so I felt like it was a waste of time to do this with a harder method when I could simply use the law of sines on this. All right, now I have actually two different sets of information here. The first one, this right here, along with the picture, just simply teaches me how to draw my picture. And then we're going to read through our own question and draw our own picture. So let's run through real quickly how this is going to be done. Francisco needs to know the height of a tree. From the given point on the ground, he finds that the angle of elevation, we talked about angle of elevation back in chapter 5, the angle of elevation to the top of the tree is 36.7 degrees. All right, so let's take a look. He wants to know the height of the tree. And so he is standing somewhere, some point on the ground, and we know that from this point to the top of the tree, we have an angle of elevation. Remember, angle of elevation starts at the horizontal and goes up. So we know that our angle of elevation to the top of the tree is this 36.7 degrees. Well, then he moves back 50 feet. So that's the distance from A to D. He moves back 50 feet. And from this second point, the angle of elevation to the top of the tree is now 22.2 degrees. So that just walks you through how to draw your picture. All right, so let's draw our own picture using Marla, who wants to find the height of a building. All right, so what we're going to look at here is she wants to find the height of a building. So let's draw our building. All right, so here's the wall of our building, and here's the roof of our building. She wants to find the height of our building, so we'll call it H for height. From a given point on the ground, all right, so let's put Marla, let's put her right here. And from this point, she finds that the angle of elevation to the top of the building is 74.2 degrees. All right, so remember, angle of elevation always begins at the horizontal, and it goes up from the horizontal, and it tells us that the angle of elevation is going to the top of the building. And so this angle, let me zoom in a little bit here, this angle is going to be 74.2 degrees. Okay, so let's keep on reading. Then she walks back 35 feet. All right, so she's going to continue walking. She goes another 35 feet from her first point to her second point. Okay, and she finds that from this second point, the angle of elevation to the top of the building, so let's go ahead and draw our angle, is going to be 51.8 degrees. So that's this guy right here is 51.8 degrees. We are supposed to find the height of the building to the nearest foot. All right, so let's name some of our points here. Let's call the first point where Marla was standing, let's call that point A. The second point where she moved to was point B. Let's call the top of the building point C. All right, so let's, I'm going to change colors here. So these are all, everything in purple is what I was handed, is what I was given. Now let's find some things and come up with a plan. So I've got here my angles A, B, and C, and angles A, B, and C, that's going to be this triangle right here. Sorry, there's a whole lot of things going on there. Is this triangle right here. So I actually already have a table set up for angles A, B, and C. The only thing I really know right now is what angle B is, and that's that 51.8 degrees. However, it's really easy to find out what angle A is. Let's look at why that is, because angle A, which is this one right here, it's an obtuse angle, and this angle that I already found, my angle of elevation, these two are supplementary. So all I have to do then is take my 74.2 degrees and subtract from 180. And when I do that, I'm going to get 105.8 degrees. All right, so that's going to be my angle A. Let's go ahead and fill that in on the chart. And then now I know 2 of my angles out of the 3 angles, and so it's really easy to find angle C because that's just going to be 180 minus the 2 existing angles. And so when I do that, I'm going to get an angle C value of 22.4 degrees. And that's this angle right here. Now remember, keep in mind what your original goal is. Your original goal is to find the height of the building. All right, so here's what I'm gonna do. Here, I'm gonna do this in 2 steps. Step number 1 is let's find out what this side is. Hey, I know 3 angles and I know a side, so I can find out easily what this side is, and we can call that side B because of the fact that it's opposite angle B. So let's find side B. And once I know what side B is, notice this here is a right triangle because we're going to make the assumption that the building, the wall of the building was standing up straight. So we know the hypotenuse of this right triangle. We know an angle. And so we can just simply use SOHCAHTOA to be able to find out what that height is. All right, so step 1, let's find out what side B is. And so I can do that by using, let's see here, there's one thing that I didn't uncover, and that is side C, which is 35 feet because it is opposite angle C. And so I'm going to use this fraction C and fraction B to be able to find side B. So here's my law of sines set up. Let's do the math by multiplying on both sides by the sine 51.8. Throw that into the calculator. We'll get this 72.1782 number. My directions tell me to round to the nearest foot. And so my nearest foot then is going to be 72 feet. Now, that wasn't what I was asked for, but it is going to help me find what I need to do. All right, so now step 2 is let's go find the height. How will I do that? I will do that by using SOHCAHTOA because this is a right triangle. Remember, SOHCAHTOA can only be used on right triangles. So using SOHCAHTOA, notice here that here's my angle. This is the side I want to know. And this is the side I do know, which is the hypotenuse. So this is my opposite. This is my hypotenuse. So I'm going to use my sine fraction. So the sine of my angle is equal to the height, the opposite, divided by the hypotenuse. I am going to let my calculator remember this whole entire decimal. Do not just use 72 feet because that will cause your answer to be incorrect because you're rounding too soon. Only round at the end. So use the entire decimal that was in your calculator. Let's multiply on both sides by that decimal, that 72 number on both sides. So in my calculator, then I'm going to get this 69.45 number. I was told to round to the nearest foot, so that's going to be 69 feet approximately is the height of the building. All right, let's cover one more example here, and then I'll stop this video and move on to the ambiguous triangle. In order to do my last example for this video, I need to remind you of something that we learned back in chapter 5, and that is how to draw bearings. So remember, if you're just given a bearing that has a single measure, you always start with north, and then you go in a clockwise direction from north. So what we have in this case, 220 degrees, starting at north, if I start clockwise, well, now I've gone 90 degrees and I've gone 180 degrees. And so go a little bit more to go 220 degrees. And that is how I would draw a bearing with just a single angle. If you're given 2 directions where it starts with a north-south and then it gives you, here's my north-south, and then it gives you either an east or west, what you're going to do is start with this guy. Start with the first one. This is going to be either north or south, and establish that direction first, and then you're going to use an acute angle east or west from that. So in this case, we want to start with our south line, and then we're going to go west of that 40 degrees. So that's how you draw when you have 2 directions, always starting with north-south. All right, so let's take a look here at example number 3. You've got the bearing of a lighthouse from a ship is northwest. Okay, so let's just start right there first of all. So let's say that our ship is right here. I'm going to call it S for ship. And my ship, I'm sorry, the lighthouse is northwest of here. So the very first thing I'm going to do is establish my north line. This is my north from the ship. And I'm going to go west of that 52 degrees. Okay, the lighthouse is somewhere on this line of sight. Okay, I don't know where exactly yet, but it's somewhere on this line of sight. Okay, so then what happens is that the ship sails south. Okay, so the ship actually takes a trip and it is sailing south. And sometime along his trip, let's say when he reaches this point right here, he still sees this lighthouse, but now the lighthouse has a new bearing. And so this is going to be his, I'll call it T. It stands for absolutely nothing. But he sees this lighthouse again, and it's still northwest, but now it's northwest 23 degrees. So again, you want to establish that north line. Okay, so here's my north line still, and I'm still going west of that north line, but now I'm going a smaller angle of 23 degrees. So now it's really easy to see where the lighthouse is. It's because the lighthouse didn't move, the ship moved, and so wherever those two lines of sight cross over each other, that's where the lighthouse is. Now, when that ship was sailing south, he went 5.8 kilometers south. And what we're being asked to do is to find the distance between the ship and the lighthouse at each location. So we want to find this one, and I'm going to call it side T because of the fact that it's opposite angle T. So this was the distance between the ship and the lighthouse the first time. And then I'm going to call this second one here S because of the fact that it is opposite angle S. And this is the distance from the ship to the lighthouse when the ship sees the lighthouse the second time. All right, so I do know what angle T is. So notice I've already set up my chart. I know what angle T is. And I don't know what angle S is, but what I can tell is that this angle and this angle are supplements of each other. And so all I have to do is 180 minus my 52, and that'll give me this angle right here, which I'm going to call angle S. So that's 128 degrees. Again, using supplementary angles. Once I know two of my three angles, I can easily find my third angle just by using adding and subtracting. And so that's going to be 29 degrees. And then the last thing that I know is side L. Side L, again, that's opposite angle L, is 5.8 kilometers. So then what you notice right off the bat with our chart is I have a full L fraction. It's going to be really easy to find what S is and what T is by just simply using my law of sines. So let's start right on in on finding S first. So we'll set up our law of sines. Once again, here's my L fraction, here's my S fraction. Multiply on both sides by the sine of 128. Throw that into the calculator. We'll get 9.4273. And let's see, it told me to the nearest tenth. So that'll be 9.4 kilometers. Let's go do the same thing to find side T. So we'll use now the T fraction and the L fraction. I already have my L fraction right here. So we'll make this equal to the T fraction. Again, this is now the proportion that I'm paying attention to. So let's multiply on both sides by the sine of 23 and throw that into the calculator. That'll give me this 4.6 number. We'll round to the nearest tenth, which will give me 4.7 kilometers. Okay, so that's going to be the end of this video, and the next video is going to deal with the ambiguous triangle. Stay tuned.